Okay, so let's take a second shot at explaining how the NRF communicates with the Pico. Uh, I'm gonna go a little slower. I have better sound and better video, obviously. Hopefully this will be better than the last video I did. So let's get started. I have the Pico and the NRF, and I'll show you in a second how everything is connected. Once we have this configured, it's going to send data to this unit here for testing. This is running, this is connected to the NRF as well through an STM32 processor, ARM processor, and it's going to control this servo. So let's see how the NRF is connected to the Pico. So I have two pictures here overlapping, showing you the layout of the Pico and the layout of the NRF24, the mini NRF24, which is the one I'm using. So I'm gonna be calling the pins by this column, not by their number, but by their GP number. So MISO or master N, this one here, is connected to GP12. MOSI will be connected to GP11. The clock or SCK will be connected to GP10, and then the chip select or CSN will be connected to GP9, and CE or chip enable will be connected to GP8. I am not using the RRQ. This is just the minimum requirements to get this communicating both ways. So this is how it's going to be connected, and this is how it looks. You can see the other two lines going to power and ground right there. Right, so if I switch my view again, so we have ground going to ground, and then this first pin going to 3.3 volts, which is coming from the Pico itself. So ground is coming from this pin, and voltage or power is coming from this pin. Okay. So let's see what I have. So I have the Visual Studio Code running. There's nothing on it. We are going to create a brand new project from scratch. Okay, so the project will be called NRF demo. Okay, so we have the folder, we'll bring it over here, and we have a brand new project called NRF demo, right? So we need to bring this file, so we'll bring it over, and we need to create the CMake lists.txt file. Okay. And in this file, we need to specify the minimum version, which is 3.12. We need to include the file we just added, which is this here, the Pico SDK import CMake. So Pico SDK import CMake. Okay. Next, we need to specify the language we're going to be using. So CMake CXX for C++. The standard is 17. The project will be called NRF. This is the output file pretty much. Okay. We initialize the SDK. Add the executables, give it the project. We don't have any executables yet, so we're going to leave it empty. We specify the target libraries, so we give it a project again. The first one is the Pico standard library. Second one, hardware SPI. So those are the two we're going to use. Now we can say Pico add extra outputs. this line will output the file, the UF2, I think is the extension. So this is the one that outputs the file for the Pico. Okay. So now that I have this, I have to close the folder, and I'll just bring it back in again. And this is just so it picks up the configuration. It does all of this for me, and then we're good to go. Right. So now we can start setting up the folder structure. So one folder for includes, one folder for sources, and the first source file will be main.cpp. So before we continue, we'll go to CMake lists and add it here. So it's under src main.cpp. And while we're adding it, we are going to add the includes folder. Not that one. That one. So project, the type is public, and the folder is inc includes, the one we created here. This is just so our folders are visible and it can pick up everything for us. So we're good. So we added this and we added this as well. So now in main, we can include the standard library and the hardware SPI, just in case we need it. We'll set up our main function, our main loop, and return 0. The next step is to create the class to manage the NRF, right? So we're going to manage this, and we're going to follow this flow. We have all the registers we need, the commands we need, and also the speed, but we don't care about this right now. We're just going to follow the flow. So let's create the class to communicate to the NRF. So first thing, we create the header. So a new file under inc, and we'll call it NRF24.h. Create a file or the source file under src NRF24.cpp. Before we continue, we're going to CMake lists and add the NRF24.cpp. Okay. Save it. Go back to the header. Here we need this, so if we call it from different locations, it'll only be defined once for the class itself. So the class we want, I have a template here for me, but you can use any of this. It just needs it's all it is a standard class. My template gives me this initializers for private and public, and the comments, nothing else. Okay. So now that we have that, we need to move this item of the header file and put it in the source file. So let me maximize this, and I'll bring this to the side so we can view everything we're doing. Include the NRF file. Also, the other ones we are going to use, which will be the hardware SPI and GPIO, and finally the STDIO.h. Actually, we don't need this here. We're gonna need it under main. All right, so that's what we have. Let's go define our class. Here we will need this too, so let's bring them over. Okay. The first well, the first variables are going to be, first we need a pointer to an SPI port, and we'll call it port. It will be a pointer. we need a way to capture the CSN pin and this the CE pin. Okay. Let me go back to the PDF so I can explain something here. So these three pins are SPI, right? But we're going to, so this, the hardware handles this for us. But this two, we are going to manipulate them directly because we know when we're supposed to set them to high or low. So we need to capture those two pins for that reason. And I'm going to add all the minimum functions required to get this working, and then we'll add the code. So we'll define the functions first. The first function we want, it's a way to read the registers of the NRF. And we'll specify a register to read, and then we'll return that register. We need to write a register as well. And when we write to a register, we need to give it the data as well. So it'll be data. There will be instances where you need to write multiple bytes. So for that, we specify a pointer and the size. Int is fine, it doesn't matter. You know, this will never go past 32 size. Okay. So once we're able to read and write, then we should be able to configure. So let's add a function to configure the module, the NRF. And once we configure, we can change the mode, right? So we can transmit and we can receive. And now that we can specify we can send or receive, we should be able to send a message. Okay, message. And obviously we want to receive messages as well. Okay. And last, if we're going to receive messages, we want to know if we have a message, if a message has come in. So we'll create a function called new message. Okay, so that's it. To initialize the unit, we need to specify, we need to give it at the beginning a reference to the SPI port. So we'll call it port, forgetting that it's a pointer. And the same for CSN and CE. Okay, so let's copy this and move it over to this one here. Hold on, let me make sure I'm recording. Yes, I am. Okay, so we'll put it there so it matches the header, and we'll copy these functions, put them down here, prefix them with a class name. Oh, this takes long. That's it. All right, so I'm gonna press Shift, Alt, and F to format. Just move everything to the left. All right, so first thing we need to do is, now that we have a port and we have a CSN pin and a CE, we can initialize SPI here in this initializer. So we'll capture the port. This references our local variable we have defined here, and this one is this coming as a parameter. Okay, so CSN equals CSN CE. All right, so now that we have those, we need to we can initialize SPI, and to initialize it, you give a port, which we have. and you specify the speed, we're going to use 1 megahertz, so it's 1 million. Okay. Um, so when you initialize SPI, you need to specify the function of this ports or pins, if you will. So this ones can be SPI, they can be UART, they can be PWM. There's many functions for those pins. We want SPI, so we need to specify the direction for those, but not direction, but the function for those pins for pin 10, 11, and 12. So we can say not SPI, but GPIO set function, and you specify the pin. So we set 10, right? And uppercase GPIO function, and then you go to, so this is all the functions that you can do. We're looking for SPI. Gonna copy it 3 times, and we said it was 10, 11, and 12, right? For the clock, MOSI and MISO, pretty much. So let's go back 11, 12. So that will initialize SPI. Now we need to initialize these 2 pins and set the direction for them. So we can say, let's see, GPIO initialize CSN 1 means output. Sorry, we're just going to initialize it. Right, same for CE. And now we need to set the direction. So direction is output because we're going to be setting it high and low. So GPIO set direction for CSN 1 is equals to output. CE, same thing. So let me go back here to the header. We're going to be changing CSN and CE high and low quite a bit. So for that reason, we're going to create a couple of functions to do that for us. So we'll call one CSN low, and this one will set the CSN to 0 and CSN high. This one will set it to 1. We'll do the same for CE. Okay. And here, now that we have those functions, I can say CE low and CSN high, which is a requirement. That's how you need to have them at the beginning. Okay, so that's just for initializing the class itself, NSPI. So now our first function is to read from the unit. So read is registers. So let's go here. And so these are the registers that we're going to be playing with, and all the ones that you can read, you can write. The commands for reading, writing, loading data, they're all here on page 45. And we are going to be reading a register, so you can see that it says that these 3 bytes have to be 0, and those are the only ones that you can read, right? The first 5 bytes. We're not gonna mask it, but we are gonna do it when we read. So we're not gonna do that part. You can do it if you want to. I'm not going to. Okay, so this will be the result. We'll set it to 0 and we'll return result. So to read or write or pretty much any register operations, you have to set CSN low. That's why we need to have it high from the beginning. Okay. So now we can say SPI read blocking, this one, give it the port, which we have, and then actually this is incorrect. You first have to write the register you're going to read. So we're going to write to, obviously we give it the port, and then we specify the register that we're going to be writing, and you know that's this variable here. right? That's what we're putting in here. And then how many bytes is 1 byte? So we're writing 1 byte. Now we can read. So SPI read blocking port, and now it's going to ask the data to send in order to read. So before a byte can be transferred, you have to give it a byte as well. Okay, so we're going to send this FF, consider no operation, and that's here, right here at the bottom or at the top of page 47. NOP, all ones is 255 or 0xFF for hex. And now we specify the buffer where we want the result, and that will be on the result. And we're reading 1 byte. Okay, ceHigh, and we're done. So it's going to write the register and then read it and put it on the result, and then we'll return it here. So now we're able to write. Let's go read. We're able to read. Now let's go write. We have 2 of the same for writing a register, so that means that we can use this one as a pass-through to this one. So write register, and we'll specify the register and the data and hardcode 1, right? So it'll pass through this one or to that one. So now we're going to write, actually we don't need to see this anymore, so I'm going to close this. Okay, so for writing data, it's, let's see, let's go up again to the commands. So for writing data, this one here, for writing a register, sorry, not data, we need to set this byte, which is number 5 or number 6, 7, 8, number 5, 6, 7. Yeah, number 5. It starts with at 0, so that would be 5, 6, 7. So we need to have that one as 1, and all the bytes to the left of it, those are the ones that we can change. So we'll copy that and specify a register. We don't have to do that. We can just use that register, and we'll do that. And then we'll do this again, and bitwise with is that what it's called, bitwise? I don't know what it's called, but we're gonna compare this against the register. So we want to make sure that only this comes across from the register. So to do that, we have to set this to 0, and we change all the A's to 1. That's 5 of them, 1, 2, 3, 4, 5. And this one is the opposite. We leave the 1 as is, and we set the A's to 0, and it's 5 of them, 1, 2, 3, 4, 5. We want to make sure that this is binary. Okay, we're good. Now we can say ceLow, SPI write, give it the port, give it the register, 1 byte, and now we can write the entire message or the entire size of data that we're passing through. So SPI write blocking port, and we are going to write whatever is in data and the size of data. And then we set ceHigh. Okay, so that's the entire write operation. Okay, this is incorrect because this is a pointer. Okay, there it is. So now that we can read and write, we can configure. Okay, so to configure, we have a lot of registers here. We're only going to do a handful of them, and we're going to take the defaults on most of them. The first one we need to do is the configuration. And to see what we need to change, we're going to go to the flow. So when you first start, you have to wait 11 milliseconds or 10.3 milliseconds, 11. And then you end up here. Then you power up and wait 1.5 milliseconds, and you end up here. So we're going to do these steps to end up here first. So this power up bit It's in the it's in the configuration. So this register config is register 0, and the bit we're after is this one, power up, which is bit number 1. And this is the column for defaults, and we're seeing that by default is 0, right? This one here. So we're going to keep this one as 1, and we're going to set this one to 1 to power up, and the rest are going to remain 0. Okay. So let's go back here, and we said we needed a delay of 11 milliseconds. We're also going to set the ceHigh just to reset everything, and ceLow. Now I can write my first register, which is the config 0, and it's 8 bits, 1, 2, 3, 4, 5, 6, 7, 8, and we set that we were going to do bit number 1, so it starts at 0. Bit number 1 and bit number 3 are going to have a 1, so this is 1 and this is 3. That's the config. Then there's a delay of, we're going to use microseconds. Since it's 1.5 milliseconds, that should be 1500 microseconds. Okay. Next one, we're going to disable I don't acknowledge because we're just going to broadcast data for this demo. So register number 0, we're going to set everything to 0. Sorry, register number 1, set everything to 0. Okay. Next, we need to specify the channel for communications. So that's RF_CH for channel, and is register number 5. So you just give it a number, and the test hardware we have communicates on channel 60. So we'll specify channel 60. So we said it was 5, register 5, and channel 15. Okay, 60, not 50. Next one is this one here. We're going to set this one, give it a name. So this is the name of the pipe for communication. This is for receiving RX, and the register is 0A hex. So right register 0A, and then we give it a name. So again, the test unit is expecting gyro C, 5 bytes, right? 1, 2, 3, 4, 5. That's how many bytes. We're going to do the same for 10. This is for transmitting. So we can copy this. And that's it. There is one more. This one. We specify how many bytes we're going to be receiving or transmitting. We're always going to be sending the maximum, which is 32 bytes. So we'll set this register 11 hex to 32. And that's the configuration. Okay, so now we have it configured, we can switch modes between transmitting and receiving. So to change the mode, well, before we change the mode, we're going to do TX, so transmitting first. So we're right here, right? So we came from the delay, power up, and we're here, standby. So now we want to change to text mode. And to change, here it says, well, this is for sending data, that's what it's telling us, but this is text mode. So to send data, we need to load data into the FIFO, set this bit to 0, right, the primary receiving, I guess, and CE has to be pulsed to high for 10 microseconds, which means that it needs to be set to 0. This has to be 0, and we don't care about this one because we're not sending data yet. But after we do that, we have to wait 130 microseconds, and then we'll be here. Okay, so let's go do that. So let's go to the register map. So this is the bit, and it's bit number 0. So we want to read the register, change the bit, and write it back. Because if we just write a 0, it's going to overwrite whatever we have in the configuration. So first we read it, and we'll call it config. Actually, we'll just call it register. And we'll read and register, and the register is 0. The configuration register is 0. Okay, so now we can say register. We say we're going to clear that bit number 0. Then we can write the register 0, and write whatever we have in our new register. And we wait 130 microseconds. That's it. Now for this one, it's close. It's almost the same. So if we go look at the flow, and let's say we're here on standby again, we want to go this way, right? We want to end up here. The path is like this, right? So you set bit number 0 or prime RX to 1, set CE to 1, wait 130 microseconds, and you end up in RX mode. So pretty straightforward. So let's do the same thing. Register, read register, the configuration, and then we're going to change the bit 0 to 1, right? If you don't remember, this is the configuration, right? Register 0, and this is the bit that we need to change to 1, bit number 0. Okay, and then we write, and we wait microseconds, 130. So that's it. So now we can do a lot. We can initialize, we can read, we can write, we can configure, we can switch modes. Now we can send a message. Right, so let's go back and see the flow again to send a message. If we are here and we want to send a message, it says that we need to have data loaded in FIFO, have this bit to 0, and have this bit to 0, but pulse it to 1 for 10 microseconds. So by calling the function modeTX, we accomplish everything minus this, minus that one, and minus that one. So now we need to load data, pulse it, and we're good to go. But obviously, we also need to tell it that we're not writing to a register, we're sending data. So that's payload, right? So we're going to be doing a payload to go out. So that's transmitting here. And we need to write this command before we write the message, and we pulse CE to high. So what we need to do is set this to that. Okay. And then we set CSN-low, SPI, write blocking. We write the to the port, the register, 1 byte. And now we can write the entire message. So same thing, SPI, write blocking, port, the message, and we're going to say 32 bytes, and this is because we hard-coded this here that we were going to be sending and receiving 32 byte messages, so there's no need to check the length or anything. It's always going to be 32 bytes for this demo. And we're done with that part, so we'll go CSN high. Now we can go and pulse this guy for 10 microseconds since we loaded data into FIFO, and we already have this. If we call modeRX, right, that's implied that whoever's using this is going to call modeRX. Sorry, modeTX. So let's pulse CE high. um, 10 microseconds, and then we send it right back to low. So that will send the message. Next one, let's read a message, right? So it's close, almost identical to this, minus this. So to read a message, we don't need to look at anything here because it doesn't tell us. But if you go to commands, now we're going to be using this command. This is for RX payload or reading payloads, incoming data. So we'll copy that and we'll specify this register to have this command. And I know we could have called it command. We'll just call command here and leave the other one as register. So ceLow, again, SPI write, give it the port, the command, 1 byte. And now we can go and read the data. So 32 bytes. So SPI read blocking, give it the port, and specify the location. The buffer is message, and it's 32 bytes. ceHigh. We're done with that operation. The last one is to, I forgot something here. So this one takes takes 4 parameters. So we're missing this one here. So we wanna read 32 bytes. We have to give it data to send 32 times so they can read it. So we're just gonna say send the 255, which is no operation. The last one is this, reading a message. So let's call FIFO status. That's the name of the register we're going to be reading. So let's go see what that is. So that one is register hex 17. This one here, right? So it's register 17, and the bit we're interested in is this one, bit number 0, RX empty, which means that if it's 1, it means it's empty, and if it's 0, there's data in it. So we have a message. So when we read it, we're going to return a 0 if it is a 1, saying that it's empty, and a 1 if it is a 0. So we're just going to reverse it. So when we read this, it makes more sense. Right? So we're saying it was 17, and now we can return, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So that will return whatever the status is on this bit, right? If it's a 1 and if it's a 1, it will return a 1. But if it's a 1 and a 0, it will return a 0. So we want to flip it. So that's it. Let's compile, make sure there's no errors. And if there is some errors, let's go fix them before we test it. All right, no errors. The errors are going to pop up once I start using it here. So let me make sure I'm still recording and this thing hasn't crashed. We're still good. It's going to be a long video. I'm going way too slow. Anyways, so include our new class that we created, NRF24, and we can use it now. So we can say NRF24, and we'll do lowercase nrf, and this one wants an SPI port, right? We'll use 1, which is that's what those 2 pins are, SPI 1. Not those 2 pins, but this one's here. See, it says SPI 1, SEK, SPI 1, TX, and RX. So that's SPI 1. Okay, and it wants CSN and CE, which is what we define, right? So it says CSN and CE. And we know CSN will be GP9 and GP8 for CE. So it's 9 and 8. And now that we have that, we can configure it, and we can specify the mode to be transmitting. Now we can send data. So let's define a message or a buffer. So we'll say buffer 32 bytes. And we need another thing here. So let's see, include stdio. And we can print. So we'll say buffer, and we'll send 45 degrees. We're sending 45, but on the test unit, it'll think that it's 45 degrees. The unit itself is also looking at position 30 to be uppercase R, and position 31 to be uppercase O. Okay, 90. So we can send the message, and we can delay for 1 second. And then once that second goes by, we'll send a minus 45, so it'll rotate the other way. And then we'll see the whole thing moving every second. So let's compile. All right, no errors. Let's see. Let me switch the view. So let me set this up. Let me move this close. This one's already connected. It's power up. So I'm gonna drop the file to this, the one we just created, and we should see it moving if everything came out correctly. So there it goes. Right? Pretty simple, right? So that's 45 degrees each way. So let's make a change here. Let me display that thing moving. So we'll change it to 60 degrees, minus 60, and let's change this to 3. All right, so let's compile. Let me set this up. So 3 seconds, and then it'll go the other way. It's full 60 degrees, and then full to 60 degrees. So there you have it. Not difficult at all. So I'll upload this demo, the code itself, and I'll put the link on the description so you guys can download it. And obviously, if you have any questions, if you don't understand it, let me know. Don't just leave a comment. Seriously, I'll reply to that comment, and I'll help you get it going. It's not difficult. This is pretty straightforward. So hope this is better than the previous one. Enjoy.